Assalamualaikum, my name is Azrie and today I'm going to present my FYP. The title of my FYP is a design of an internal erosion preventive system for Senggarang Coastal Embankment subjected to tidal assault. So for the first one is the abstract. Embankment can be described as a structure built as water retaining storage or to stop water from flooding using soil and stone as the material. Due to the constant exposure to water, high tide and low tide, there are failures that can happen to the embankment such as seepage, which lead to internal erosion, instability of the embankment and the piping. The Senggarang Coastal Embankment are showing signs of facing severe seepage phenomena and internal erosion. The embankment are slowly damaged by seepage and cause the embankment to slowly collapse and leads to critical flooding risk to the nearby residents. Hence, in order to improve the stability and strength of the embankment to contain the tidal assault, also to reduce the seepage phenomena, a drain needed to be installed such as sand drain and gravel drain. In this study, we will be comparing the effectiveness of drain to reduce the seepage problem. The drain used in this study are sand drain and gravel drain, which were modeled using Plaxis 2D software. Plaxis 2D software is a computer program that performs finite element analyses within the realm of geotechnical engineering, including deformation, stability, and water flow. In summary, the deformation and discharge of seepage for the embankment with drain is lower compared to the embankment without drainage. Therefore, the embankment installed with drain is one of the ways to reduce seepage problem that is occurring in Senggarang Coastal Embankment. Next is the introduction. So this study is actually to analyze the seepage occurring on the Senggarang Coastal Embankment, which is located southwest of Indonesia. The Senggarang Coastal Embankment is an old embankment and has been patched multiple times, and there is no past record of its construction. The simulation will be made by using Plaxis 2D software to simulate an embankment with and without draining. There will be two types of drain, which are gravel drain and sand drain. The simulation will be only focusing on the embankment itself and not the foundation. The foundation will be set as bedrock, which is a non-porous and have a strong resistance against deformation. The data obtained will be analyzed and selecting the best drain for the SE. The main objective of the project is as follows: to analyze the seepage characteristic of Senggarang embankment constructed with a drain system installed into it, to analyze the effective of drain inside embankment against deformation, to recommend a comprehensive internal erosion prevention system for Senggarang Coastal Embankment to address the escalating seepage problem via an existing case study. Next is the literature review. Internal erosion is a major source of instability in hydraulic earth structure, including dams, dikes, and lifts. Any process by which soil particles are eroded from within or underneath a water retention structure is referred as internal erosion. Internal erosion is a particularly dangerous process since it destroys a structural integrity over time in an unnoticed method. Internal erosion has been responsible for 46% of all embankment dam collapse throughout history, becoming one of the biggest concerns linked with embankment failure. Next is the drainage system. Drainage system is important in modern day embankment construction. It provides safety and lower the chances of the embankment to collapse on its own weight due to seepage problem. The drainage system will reduce pore pressure on the embankment and control the movement of seepage and convey it out of the embankment. Some of the existing drainage systems are vertical drain, chimney drain, blanket drain, and toe drain. So next is the Plaxis 2D. Plaxis 2D is a powerful and user-friendly finite element package intended for 2D analysis of deformation and stability in geotechnical engineering and rock mechanics. Soil and rock mechanic behavior may be simulated to varying degree of precision. Hooke's law of linear isotropic elasticity, for example, is the most basic accessibility stress-strain connection. It is often too rudimentary to capture crucial element of soil and rock behavior since it only required two input parameters, namely Young Euclides and Poisson ratio. The linear elastic completely plastic model, more column, is a first order approximation of rock or rock behavior. of soil. Next is our methodology. So as you can see, here is my flow chart. So first is start, and then our title selection, then the lecture review, and it will split into two. For the first one is information preparation for primary data. The soil property are collected from past study, dimension of the environment, and the property of the type of drainage system. And we will be simulating the creation using a model of the CE was construction by using Plaxis 2D software. And then we will do an analytical simulation. This is the geometry line, material site, mesh generation, initial condition, and calculation. Next is the preparation of secondary data. Is performs of each drainage system, finding the performance of each drainage system from past journal, the standard specification of embankment from past journal, and compiling the data into a table. And then after that is our result. We will do analyze and discussion, and then finally our conclusion and recommendation. And here you can see this is my model of embankment inside the Plaxis 2D software. The height of the embankment is 6, the foundation of the embankment is 6, and the height of the embankment is 3 meters. The length of the foundation is 71 meters. The water level will rise from 1 meter to 2 meter and 3 meter. And here is our calculation phase, the 1 meter, 2 meter and 3 meter. The consideration phase is to find the excess pore pressure, the displacement, and effective stress. And the seepage one is to find the discharge of seepage. Next is result and discussion. As you can see here, there is 4 graph, which is the first one, water level versus total displacement, water level versus effective stress, water level versus excess pore pressure, and water level versus discharge of seepage. Based on the data above from the graph, the embankment with drain help to reduce the total displacement, the effective stress, the excess pore pressure, and the discharge of seepage. Reverend and Senggarang reduced the discharge of seepage by 26% and 16.5%, while also reducing the displacement by 5.8% and 4.1% respectively. In this study, it can be seen that gravel drain works better compared to sand drain, and solid drain can help the Senggarang Coastal Embankment to fight against seepage problem due to tidal assault. Next is the conclusion. In this simulation, drain system help to reduce seepage and help stabilizing the embankment while also increasing its strength. Therefore, the embankment installed with a drain is one of the ways to reduce the seepage problem that is occurring in Senggarang Coastal Embankment, and also increasing the stability of the embankment by decreasing the excess pore pressure and discharge of water. Embankment should be equipped with a way to counter seepage problem, which leads to internal erosion, which is the answer to this question is drainage system. That is all for my presentation. Thank you.